All right, so I picked 3 different formulas, one of each type, one at standard, one at vertex form, and one at factored form. But I didn't ask you these same questions on each one. I have developed what goes with it for a certain reason, okay? So on this question, I ask you everything about transformations. I did that because this format tells you the transformations without graphing it. And you don't have to write any of this down. This document is in Canvas if you want to go back to it, y'all. I don't think if you want to write something down, you may want to write down something more specific than just the question. So let me go back and give you the information that vertex form tells you about. If you remember, vertex form looks like this. If I was going to write something down, this might be what I'd write down. So if this is negative, what does that tell me? Yeah, it tells me all this right here, doesn't it? It tells me if it opens up or down, which tells me if it rises or falls, which tells me if it reflected or not. So in this particular format, it tells me even more than that. But it tells me that so far. Then this A also has the greater than 1 and less than 1 concept, and that's the absolute value of that, by the way, not A by itself, but take the negative off and make it positive. And that's what helps me to tell the compressed, stretch, or neither, because we know it does what if it's greater than 1? Compresses. All right. And so that means this one stretches. Now, let me talk just a minute about that. So suppose you graph a graph, or maybe you have a graph, and I ask you that same question, compressing or stretching. If you count up 1 and over 1, and that dot up 1 and over 1 is on one side of that line or the other, that tells you if you stretched or compressed because it's supposed to be there. So if it was supposed to be here, and now it's over here, what did I do to it? Stretched it, didn't I? I made it wider. If I have one like this, and I count up 1 over 1, and it falls out here, what does that tell me? Compressed. And then if I have one that I count up 1 over 1, and I'm on the line, that's where it's supposed to be. That's a neither. So see, I could give you a graph, and you should be able to tell me if it stretches, compresses, or neither from just that little simple up 1 over 1 from the vertex. Because the vertex on most graphs for x squared by itself is up 1 over 1. All right, so it's nice to have the formula because that number gives it away, doesn't it? Then this up, down, left, right thought over here comes from right here for right or left, and over here for up or down. But what's so special about this x part? It's opposite. Well, here's why. The formula has a subtraction sign in it. So that means whatever you put in here is going to do the opposite. So like, for example, if I wanted a formula to go right 2, I'd put a 2 in here. And that makes it look like x minus 2, which looks the opposite, right? Or if I put in negative 3 for going left 3, then negative 3 and negative turns into a positive. And that's why it's always the opposite, because it has a subtraction sign in the original formula. In order to pull that back out, I have to do the opposite. So this format is really great for asking these questions, and I didn't have to put anything in my calculator. Does that make sense? Now, if I ask anything else, I might have to put something in my calculator, or I might have to hand calculate something. Because I can't get y-intercept out of that as easy by just looking at it right. I can't get zeros of the function out of that by looking at it. I can get the vertex. Where's my vertex? Where did it just move to? Opposite. So negative 2, negative 5. So 2 to the left and 2 down. I mean 5 down. So the key here is I could ask you these questions, and this format gives away a lot of that information. All right, let's talk about the next one. This format doesn't give a lot of information away. It definitely doesn't tell me much about up, down, left, right. Still tells me if it stretches, compresses, opens up or down, rises or falls, right? They all can tell you that. But it can't tell me a thing about up, down, left, right if I don't get the vertex. So with this format, I could ask you some of these questions, and only one of these questions can I just look at the formula and know the answer. Which one? That's right, zeros are the function because this is a factored format. So I know what my zeros are because I pull them out and make them the opposite, just like I do when I want to know something about the vertex. So these I would have to put in the calculator, or I could take these two zeros of the functions and find the midpoint, and then I know where my vertex is. I still might want to calculate something with it, but I could use some hand calculations. I could put 0 in for both of them and get my y-intercept, or I could go to the calculator and get those values. I have some options, but the only one I can look at it and tell which one it is zeros of the function. And then that is not the problem I thought I put up there. Well, hold on a minute. I got busy typing and typed what it was I was multiplying out instead of what I actually was doing. And where did I write that down? Wait a minute. Yeah, do writing. X squared minus 12x plus 36. All right, this one's a standard one. So in the standard form equation, I might ask you for increasing, decreasing, domain, or range. I could also ask that about factored form because that would be some really good questions to ask. All of these, no matter what I ask you on whichever one it is, you got to have the vertex. If you don't have the vertex, you can't answer any of these questions that ask you specifics about the graph. So based on these three questions so far, is there something there that you see that you don't know how to do, no matter which format it is? So we don't have any trouble finding the vertex so we can see the axis of symmetry and which one of these is increasing or decreasing on each side of it. Or that the range is always y is greater than or equal to or less than or equal to the y value in the vertex. No problem there? And that you convert that to your infinities. Did I clear up some mystery on infinity yesterday? Did that help y'all a lot, what I talked about with infinities? To get them on the right end of the infinity? Because it seems like that's the most common mistake, is saying infinity comma 4 instead of saying 4 comma infinity. All right, so what do you feel about these first three questions? No matter which set of these questions I ask you, and more than likely, I'm going to be real specific about and not do all of them to save us a little bit of time. But I'm being real specific because of that particular format might be better for that kind of question. Like, vertex format's better for telling up, down, left, right. Factored format's better for giving me zeros of the function. Nothing's better for this, except unless you know where the axis of symmetry is in the vertex. So in that case, it wouldn't really matter which format I give you. I mean, it's a little easier with vertex format, but not any, it doesn't matter if it's standard or factored form. This right here, you got to know the vertex and axis of symmetry to get it. So do I need to go more in depth on any of this, or does everybody understand the directions and everybody understand what I'm looking for? We okay? Shaking a few heads, and the rest of you looking at me like a blank stare, so I don't know if that means I'm okay or I'm confused. Well, we'll look at a little more, and if you want me to go back, I can. Okay, another thing I want you to be able to do on your test is explain the transformations that happen with each notation to a parabolic graph, okay? So in these notations, I'm expecting you to know what was on the first slide. Okay, so let me bring that first slide back over here for just a second and copy that. except for in behavior. In behavior is not a transformation, okay? And neither is opens up or down. That is not a transformation. So on this set of questions, I just want to know these 4 things. Does it move up, down, left? Does it reflect? Does it compress, stretch, or neither? The difference between this and that first question is there will be no list. I expect you to know what are the words that you should be giving me for transformations. For example, there's only a -2 out here. What should I be telling? Reflex is okay, because that's important because it starts with a negative. Anything else? Compress. So this one would have 2 things about multiplying because of the reflection and the compressing. So if you don't reflect, you only have 1 thing. But if it reflects, you have 2 things. All right. What about this -3 way over here on the end? Down 3. All right. Now, what about this one right here? What does this negative right here on the 4th question down do? Reflects, but does it stretch or compress? No, it doesn't, does it? Because -1 doesn't do anything when you take that and make it absolute value. It turns into a 1. And that's not greater or less than 1. So that would be a neither, right? Well, that's the key. If I don't give you this list over here, you don't list it. You wouldn't write neither. You would just not list it. When I give this list, I have neither for you to choose from. But when you're telling me transformations, if it's not going to do anything to it, I don't write it. Good point. What about this? Parentheses, x minus 1, what does that do? That's correct. You do opposite of that, makes it +1 to the right, and then this -4 on the end, down 4. So you'll have a set of questions like this. The difference is you're not going to have this list there to talk about, okay? There are 4 kinds of transformations. This particular test is testing 3 of them. Reflection, translation, which means did it move up, down, left, right, or reflect? Up, down, left, right. And then dilation, did it get bigger or smaller? The 4th one we don't do with this because that's rotation. Hard to rotate a formula at the same time that you're doing all this to it. It doesn't work that way with algebra. So we're only doing 3 of the transformations: reflections, dilations, and translating, which means slide it all around. All right, is there anything there you see you don't understand other than my weird fractions I couldn't type because I couldn't get quick enough to get over there and type my fractions right? We okay? They'll be typed right on the test. The last one? Okay, let's talk about the last one. That's a good one. All right, on this last one, there's nothing in front, right? And there's nothing on the end for the up or down. And there's no adding or subtracting inside, so there's no left or right. But there is something inside in front of x. And it affects your problem somewhat the same as having that -2 out here. Except for one thing. It's inside of a square. How does that affect it? It doesn't reflect. You see, if you put this inside of x squared, the negative goes away. But it still does what 2 is going to do, because 2 squared is 4. And 4 does what? Compresses, right? And 2 compresses. So if you look at that number, no matter what you do, what kind of number it is, if you square it, it's still going to do the same thing that it did before it was squared. The big difference is when I put the negative on the number here, it doesn't reflect because it squares out. Now that's not true about every function. That's true about this function. Anything else? Right, it's just compress. So you'll have a small set of questions like these where I'm just asking you to tell me what happened based on the numbers with no formulas being given. See, I'm not giving you a formula to plug it in and put it in your calculator and compare it to the original formula. I'm just asking you what did it do. So eventually, when we've studied a few more functions, I might say, okay, it did this on the 4th problem, and now it's doing this. What was the end result? Because I could say move up 2, down 4, or next, and you have to tell me, oh, up 2 and then down 4 from there would be where? What if you went up 2 first, and then you went down 4 seconds, where would you be at? -2. So that would mean that I really, altogether, went down 2, didn't I? So that's where we're going. We're going to eventually put more than one together. But for right now, we're just going to do one at a time to make sure we understand what each position does. All right, the last thing I have for you, I have 4 word problems in here, a little variety. I have one word problem where it asks you, like, how high was it in 1 second? How long did it take to get more than 30 meters high? What's the maximum? When did the hit the ground? Anything there sound unfamiliar? Let's see. How high was it in 1 second? Don't you want to go down here and look up 1 and go up on the table and look up, see what it is or value? Okay. How long is it 30 or more high? Okay, let's say 30's here. And 30's also here, because it may have passed 30 on the way up and it may have passed 30 on the way down, unless that was the maximum, right? If that's the case, how long it's in the air would be from here to here. I'd need to know how much time that is. How would I figure that out? Right, okay, I need to get the x values from these 2 points and subtract is correct. Because this will be something 30 and this will be something 30. For example, this might, let's say, be 2:30, I don't know. And this over here is 9:30. Well, then it took 7 seconds if that was the case, right? So you just need to look those 2 values up off your graph with the second count number 5, enter, enter, enter. Y2 would be 30. And of course, we all know how to get the maximum with the maximum button. If we don't do it by hand, this would be a great one for the maximum button. And then eventually, it'll come over here and hit the ground, and we know to put what in our calculator to hit the ground? Y2 is 0. So this can all be gotten off the calculator. It's just a matter of knowing which functions you'd need to do that with. Now, you could have something like this one, where a figure is already labeled, and they're asking you to figure out x, or they might ask you to also figure out the lengths of some of the sides. This one didn't ask for that, but I could ask for that. Any problems with doing Pythagorean theorem? Now, did I say you had to do it by hand? No. Didn't say you had to do it by hand, did I? So that means you could set the equation up and just do y1, y2, and 5x. Because at the end of the year, it's a calculator active exam. So sometimes you're going to have to use your calculator to speed things up because you don't have time to work all the questions by hand. But sometimes it's quicker to do something by hand. Not necessarily on that one. Why does it say round to the nearest thousandth? Is because I can vary how many decimal places I want. How many is that? How many? 3 is correct. Because it's tenths, hundredths, thousandths. All right, what about this one? If you have a relationship between what you sell something at and how much revenue it brings in, then I could ask for a maximum revenue. I could ask you what price is that maximum revenue causing, and the price happens to be the same thing as X in this problem. The revenue happens to be the same thing as Y. I could tell you to determine the revenue if it was sold for $50, which is the selling price. So where do I put this $50 in, X or Y? X, because P in this problem is your selling price. And then down here it says, what should the glasses be sold at to break even? What does break even mean? Yeah, 0. No profit, no revenue whatsoever, breaking even. So you'd want to put Y2 as 0 for that. And it would tell you how much the price should be, so that you'll break even. So, anything different there in that word problem? Okay. So in another one, I might give you a figure and ask you to label the picture. This one talks about a rectangle's length and width. So you can set up an area formula. And then once you get whichever letter you're calculator gives you, you'll have to go back and find the other letter. So like if you calculate up width, then you'll have to plug it back in and find your length, because I asked for the dimensions. And when you tell somebody dimensions, like 4 by 5, 5 by 7, you know, put your length first, then your width, with your units on it, if there are units. This one didn't have units. Well, length of a rectangle is, what do I write for that much? Subject's length, the verb is, what do I write for that? L equals 4 less. How do you make something 4 less? Subtract 4. How do you make something twice the width? 2W. What's this side then? That's right, it's W, because if the other one has an expression of W, we hope that this one's W, but it don't have to be. You know, I could have said something else. I didn't have to compare that to width. I could have compared them both to something else, but it just made more sense to make one comparative to the other. And then, what is the area formula for a rectangle? Length times width. Okay, so I put the length in a parentheses because it looks a little more complicated, and multiply it by the width and set that equal to 70 and do y1, y2, see where it crosses, and find my W. And then once I find my W, I can go back and plug it in and find my length. It don't matter. This can be y1 and that y2, or this can be y1, this is y2. It doesn't matter. Most people like putting the second one as the number and the other one with the letters, but it don't matter. It's going to graph them both, and they might not cross on Zoom 6, but they're going to cross on some Zoom. And how familiar are y'all with Zoom Fit? Okay, let me throw this one in here real quick. That's another great Zoom. So we had parentheses 2W minus 4, right? So then I'll do that times X on the outside and put 70 down here. And if I go to Zoom 6, Zoom 6 is a 10 by 10 screen, so I'm not going to see 70, right? Okay, Zoom 8, you have to press enter. That is a 40 by 30 screen. Can you see how it has more marks one way versus the other one? It goes by 10s. Zoom 3, which also makes you press enter. See how it's squeezing it in and compressing it? I can see it crosses twice, but it's not real easy to see, is it? So Zoom, let me go back to Zoom 6 so I can go back to the center of the screen. Zoom 0 is Zoom Fit. And what Zoom Fit does is say fit the graph to the screen. And sometimes that works and sometimes it don't. Sometimes it might make it so where you can see part of it and not the other part. Especially if you're wanting like your max or min, because I'm not sure that I can see my max or min. I see it down here somewhere, but I'm not sure that's the bottom of it. So it's something you can try as a Zoom with Zoom Fit. But if Zoom Fit don't show you what you want to see, go back and go to Zoom 6, 8, 3, and try that. But sometimes Zoom Fit works right after Zoom 6 and gives you a great graph. Now, am I going to want this negative answer over here? Because width can't be negative, right? And since our variable is one of the side lengths, I know that can't be negative, so I want that one way over there. Does that make sense? And then once I get that, I plug it back in and get length. Does that answer your question? Okay. So in these problems with the word problems, I'm not really expecting you to do as much by hand. I'd rather you did more with your calculator, because these numbers may not be very nice. And some of them may not even have whole number answers. I don't know if they do or not, because I'm still in the process of making it, and sometimes I make a bad one, and they just don't have whole number answers. So, is there something here you'd like to talk more in depth about in terms of the first 3 questions, or the up, down, left, right questions in the middle, or word problems? Okay. So, with Pythagorean theorem, what's the formula again? Okay. So, x squared, this squared, add them together, right? Set it equal to this one squared. So, if you have a Pythagorean problem, you can take the 2 legs put parentheses around it to square it, if it's got more than just an x, and put a plus sign between it. And then put parentheses around your hypotenuse to square it if it's got more than one thing in it. Yes? Yes. Uh-huh. So like if the answer came out to be 7 for width and 5 for length, I'd say 5 by 7 with the units, whatever units was on it. Now that one didn't have any units, but mine will on the test. So I have x squared plus 2x quantity squared equals 4 minus x quantity squared. Now I might would square that out just because it might make it easier to type 4x squared. And then again, I might not, because what if I did that wrong? Because I noticed some people forget to square both of them. And that would give you the wrong answer. So you may not want to leave anything to chance. You may want to just set your formula up, put all of this in y1, and put all of this in y2. Now when you do that, you're going to get x. And this question here only asked me for that. But I could ask you for the length of all the sides. So once you get this answer, you may find that you have to go back and plug it in these two to get the other two answers if that's what I asked for. Because I could just say, well, how long is the hypotenuse? Do you want me to go further than this? I don't know. Let's see. X squared plus 62x minus x parentheses squared. Zoom 6. Well, I'm going to try Zoom Fit and see if it looks any better. Well, it looks better for this point, but I was thinking it might cross more than one time, right? So I could get that one, but it's negative. Can it be that? Well, I wouldn't think so. Go back to Zoom 6, see where I got to go. But there's a positive one over there on that side, isn't there? So second count, number 5, enter, enter, enter. Come on. And it tells me 1.24. Now, did it say something about rounding on this one to the thousandths place? So if that's the case, that'd be 1.236, wouldn't it? Now, that would be x. Do I need that y value over there? No, because it didn't mean anything. So then I would take that 1.236, and that would be the answer to this question because of the way I wrote it. But if I said how long is the hypotenuse, then I'd go 4 minus 1.236 to get the hypotenuse. Okay, anything else? So we feel okay about transformations, and we feel okay about what your quiz was on the day before, where I pick off these little pieces and ask you about different things for different formulas. Because, for example, in this problem, as long as you had the vertex, you know where your axis of symmetry is, right? Because this is all about x, and that's all about y. So in this particular case, I could do -1 times -12 over 2 times -3, and get 12 divided by -6 is -2. And then I could go in there and I could say, okay, this one opens this way, and here's where -2 is. What's the left doing? Increasing. So that makes it x is less than -2 because left is always less than, right? And then that makes this the other one. So if you can figure out what the left is, you know the right's the opposite. But then you could go back and plug that -2 in. And whether you do that by hand or whether you do that on the calculator is totally up to you. Well, once I go back and plug that -2 in, let's say LB squared is 4. 4 times that's -12. That times that's 24 plus 36. That's 48. Is it less than or equal to or greater than or equal to? Consider I'm doing a max. This is the top of my graph right here. Less than or equal to 48. So whether you hand calculate that 48 or you let the calculator do the value button for you, I don't care. But the key here is I want you to be able to give me this then in the interval notation. So let's talk about that real quick. So this one would be negative infinity up to negative 2, and this one would be negative 2 to infinity, because you got to start with negative infinity if you're doing less than. And down here, this would be negative infinity up to 48, but what's different is there's a bracket on 48 because I want to include that dot, where this one's just negative infinity to positive infinity. So be careful. A lot of you are leaving this bracket off on range, and you got to put a bracket on the number. Infinities never have brackets, but in range, the number does. All right, we'll see y'all tomorrow.